Kia ora. Let's look at the hydrolysis of polyesters. Now, the same thing, hydrolysis means adding water to the molecule and splitting it up into its acid and alcohol monomers. So here we've just got the simple one ester link that you would look for, and you would break it between the carbonyl and the oxygen. So the OH of the water will add to the carbonyl, and the last hydrogen will add to the oxygen. And so you can see there's the OH onto the carbonyl and the H onto the oxygen. Now, under acidic conditions, my COOH is acidic, and so it will not react further with more acid. My alcohol is neutral, so will not react with an acid. So those are my products of acid hydrolysis. If I do base hydrolysis, it's exactly the same thing. I break it down there. I get the same products, but I do another step. My COOH is acidic, so will react with any base that's there. So I form a carboxylate salt. So anywhere where you're going to form a COOH, make sure you turn it into the carboxylate salt. If you don't know the cation, if you're not given the cation, you just are told it's base, then you just leave out the Na plus and you just leave it as COO minus, and that would be fine. Again, the alcohol is neutral and so won't react with a base, so that remains unchanged. So here's a polymer. Now see, what would the products be under acid hydrolysis and under base hydrolysis? You can pause the video and draw it. Okay, let's have a look. Again, the first thing you do is you look for all your ester links. Here it's where it joins on the next diol. So you break it between that carbonyl and oxygen, and so hopefully you'd be able to see you have this sort of molecule. There's that phenyl group, which you may be given the exam, but you certainly don't need to know about it. You just simply copy it off, and there, from that carbon, you've got the carbonyl and another carbonyl, and so you just simply add the OH and the OH. Then you also have the diol being formed. That comes from this bit over here, where a hydrogen has added on to each of those oxygens. So that is the acid hydrolysis. The base hydrolysis is again identical, but you do the next step where you have to take the H off this OH, because that's an acidic hydrogen. So you look for wherever you have a COOH or a COOH can go in the other direction, and you remove the H and put a negative charge on. And then if you know the cation, you would add the cation. Again, the diol does not change because it's neutral, so won't react with the base. Kia ora.